Okay, hello. Good morning. Let me know if I am audible so that we can start. Am I audible? Is the voice clear? Can we start? Okay. So the topic we are going to learn today is we are going to start as gravitation. This is from class 9th and all students are welcome. So good morning all, and this is a new fresh start for physics. We have already completed two lessons, and that is force and laws of motion. But today what we are going to go for is gravitation. This is one of the very important topics in terms of your preparation of physics. This topic is not there in your 10th standard, but this topic is again going to come in your 11th grade. So as this topic is again going to come in 11th, so you cannot afford suppose let's say to not pay attention to this particular topic. And gravitation is so simple. If suppose let's say you are very much well versed with the numericals of motion and force and laws of motion, gravitation is very easy because it doesn't have many formulas. The main advantage of gravitation is that it doesn't have many formulas. There are just basically you can say two formulas in general. There are only two formulas in general for your syllabus. So there are not too many formulas, there are not too many extensions. You have to use your previous knowledge for solving the questions. So it is not that much hard. What makes this topic hard is just about the suppose let's say the concepts. If you understand the concepts, then understanding or solving the numericals, it is not that much hard. So numerical is definitely there in our syllabus, gravitation, but what we don't have, or suppose let's say as compared to the previous lessons, what we don't have is the difficulty level. The difficulty level of gravitation is very much simple as compared to the previous chapters which you have seen. So it's very much simple lesson, easy, but only if you pay attention. Otherwise this will again become some kind of other nuisance. Okay, now this is the syllabus what we have. What we have for our entire suppose let's say this gravitation is something like this: gravitation, then free fall, mass, weight. And what I have done is I have written the points according to our NCERT book. So you can do one thing, open your textbooks, and I have written the points according to NCERT. So you have to just compare the points, that is 10.1, 10.2, 3, 4, 5, 6 and 7. So total how many points are there in our textbook? We have 7 points. Please open the book and let me know in the comment section. Have you opened your textbook? Have you gone through all the points? Open the last page. And can you please check what is the last point? So let's say the name and the number. Is it 10.7? Please confirm in the chat box, write it down. Be fast and fast. So is it 10.7? Is it 10.7? Yes. So the syllabus which has been deleted for class 9th is you have syllabus only till 10.4. Your syllabus is only till 10.4. 10.5, 10.6 and 10.7 has been deleted. 10.5, 6 and 7 has been deleted from your syllabus. So can you do one thing? Can you just please write it somewhere on your textbook somewhere that 10.5, 10.6 and 10.7 has been deleted. So these topics are not there in your syllabus. These are deleted. These are not going to come in your exam, not going to be asked. So we are having only 4 points, that is gravitation, free fall, mass and weight. Okay, can we start now? Can we start with the syllabus? I hope everybody has understood which part has been deleted and which part is there for our syllabus. Can we move ahead? Okay, so the first thing what we are going to understand today is what exactly is gravitation. This gravitational force, if you remember in class 8, I don't know whether you really remember it or not, but in class 8 you had been taught like what are the forces and what are the types of forces. So you must have gone through forces like contact forces and non-contact forces, contact and non-contact forces, right? That was something which was taught to you in your class 8th. And in non-contact forces, there was one force in peculiar which was very simple to understand, very easy to comprehend, and that was gravity, gravitational force. That is what we are calling as gravity. So that was very simple, right, in class 8. So that was the only force which was very easy to us to understand. Now the definition which we had seen in class 8th, let us go with that definition first and then we will change for class 9th. So in class 8th, what definition you had given was gravity. We are going with the definition of gravity. Let us see what you had seen in class 8th and what needs to be changed for class 9th. In class 8th, the definition which you had used was gravity is nothing but force of attraction exerted by earth on the particles or objects, you can say objects on the objects present on earth. Right? Okay, so that is the definition which you had used in your 8th grade. Very simple and very let's say simple to comprehend. Force of attraction exerted by earth on the objects present on earth, right? This was the 8th definition. But now you need to change. Now you need to change that definition, because according to this definition, it means that only planet Earth has gravity. According to this definition, it means only planet Earth has gravity. Only planet Earth. Is it true? Only planet Earth has gravity? Write it in the comment section. Do you think that only planet Earth, only Earth has gravity? Now that is something new, right? Only Earth doesn't have gravity. There are different planets which have their gravity, right? Okay, so that is so much true. Correct? Now, so as Earth has gravity, but other planets also has the gravity, so we need to change the definition. Okay? Now, question is then why this definition was given to you? Why this definition was given to you? Because you were in which one? You were in 8th standard. You were in 8th standard, because of which your age was very much young. So CBSE didn't let's say change the syllabus. They just said that it is easy for students to understand if we let's say limit the knowledge of gravity to earth. If we limit the knowledge of gravity to earth, students won't get confused. So it was just for your understanding part, because you were very young. So the definition was very much simple for you to understand, right? Now let us change it according to 9th. Let us change according to 9th. Now according to 9th, you have to use the same definition, force of attraction. That won't change. The first letter we will write it as it is, force of attraction. Now we are changing the definition according to standard 9th. Force of attraction, exerted by earth. Now we are going to replace that earth. We are not going to use earth. We are going to use particle. Okay, but what we are going to say, this is also we are going to replace with particle, and object also we are going to replace with particle. Now there won't be earth, there won't be object, there will only be particles. Now we'll see. Force of attraction exerted by any two particles in the universe. Is called gravity, या फिर gravitational force you can say. Are you understanding now how we have changed the definition? First we had said that force of attraction is nothing but force of attraction exerted by the planet Earth on the objects present on Earth is gravity, right? That was standard 8th. Now standard 9th we have to change, force of attraction exerted by any two particles in the universe is called as gravitational force. But we have to say force of attraction between the two particles, right? Force of attraction between the two particles exerted by two particles amongst themselves, you can say. Amongst themselves, if you want to really change the definition, you can use the word amongst them. These words you can add for extra definition information. So force of attraction exerted by any two particles amongst them in the universe is called as gravitational force. So you can take any two particles on, suppose let's say in the universe, and they will have gravitational force. Of course it will be high, it would be low. For example, if somebody is standing on Earth, there is one, suppose let's say we have a pen which is on planet Earth, and there is Mars, and we have another, suppose let's say a mobile on Mars. So there will be still force of attraction between mobile and pen. mobile and pen. But of course the distance is very large, so hence that gravitational force is very low, hence our pen won't be traveling from earth to the Mars. Are you understanding? Force is there, but the gravitational force is very low, very and very low. So very low. Are you understanding this? I cannot just let's say give a number particularly like how much, but you can just remember this, that it's the force is very low, and because of that not every two particles get attracted to each other. Even though at there are a larger distance every particle is attracting everybody, but they don't get attracted only because of the reason that the force of attraction is very low. That is the main reason. Are you understanding this? That is the first point. Okay, now first definition, have you understood? First definition. So can we say this is the new definition you are going to use? Can you please write it in your textbook somewhere? You have lot of margin, right, in your textbook. Suppose let's say if this is your page, so if this is your first page, like left hand side, so everything is written here, right, in 2 columns. But you have lot of space. You have lot of space here on this side and this side and this side. Can you do one thing? Can you write down definition somewhere? This definition which you can use. Gravitational force is the force of attraction exerted by one particle on another. That's it. This is the most simple definition you can use even in your exams. Most simple definition. Kindly write it in your textbook. Write it in the comment section also. Are you understanding? Have you written? Write in the comment section. Have you written everything? Fast and fast and fast. Gravity is the force of attraction exerted by one particle on another. Write it in the comment section. Have you written? Have you written everything? And you need to be, suppose let us say, yes, you need to be interactive. You need to write it in the chat box. Unless and until you write it in the chat box, I won't be able to understand. Yes, constantly you can write it there. Okay, have you taken the definition? And please write it in your textbook. Okay, now we can go for the next point. We can go for the next point now. Okay, now the next thing what we are going to understand is you already know gravitation is nothing but a force, right? Gravitation is nothing but the force. Now a basic formula which you have for force is equal to mass into acceleration. This is the formula, right? Force is equal to mass into acceleration. But have you specified which force you are talking about? Have you specified which force are you talking about? The force has not been specified, right? It can be any force. It can be electrostatic force, it can be muscular force, it can be gravitational force, it can be any kind of force, right? It can be any force, any force. So this formula what you have, it is actually of any force, like it is of a general force. The formula, it is of general force, it is not about a specific force. It's not about a specific force, because according to our information there are various forces which are there, that is muscular force, then we have frictional force, then we have gravitational force. Don't you think we require a separate formula? Don't we require a separate formula for gravitational force, because that formula is already a very general format, right? So we need a specific formula for gravitation. Are you understanding? We need a specific formula for gravitational force. Agreed? Agreed. We need a specific formula for gravitational force. Yes. Kushal Jain, you can use that definition. Can we say force of attraction between two objects is called gravitational force? Yes, you can use. You can use. No issue. That is the same thing, Kushal. No, you can use that. Specific formula for gravitational force. Understood the need? Understood the need? That what exactly is the needed part? Specific formula for gravitational force. Okay, so we need to create a new formula which will give us the idea about gravitational force, right? And this was done none other than Newton. Newton has given the formula for this. So specific formula was needed in case of gravitational force, and this was done by none other than our scientist, and that is Newton. Okay, Newton has done this. Okay, have you understood this? Okay. Sonia Gaikwad, what you are saying, you have to write it. Okay, Sonia Gaikwad and other students. Suppose let's say you are in 9th standard now. Whatever you feel which is important for your study, you are supposed to write it. You are not in 8th standard or 7th standard wherein you are required to ask your teacher whether I should write it or not. Whatever you feel is important for your study, you write it, because you are in 9th standard now. You are supposed to understand the things, you are supposed to write down the things which you feel important is going to help you in your study. So I am not going to say every time that please write this, please write that. That is up to you. You are supposed to write it. Fine. Okay. Now let us move ahead. So who has given this formula? Newton. And Newton has given only two statements. Newton has given only two statements. Now can you please, first we will understand the logic of direct and indirect variation. Can somebody please tell me, suppose if I am writing down here as x and something like this, and x as something like this. Let me call it case 1 and case 2. Case 1 and this is case 2. Can you please write it in the comment section, which of the two is direct variation and which is indirect variation? Can somebody give me the idea? Which is indirect and which is direct? Which is direct variation and which is indirect variation? You just have to write down in the comment section. Write down your answer, because unless and until I am taking it from very much of the basics. If you connect with me, if you are interacting with me, it will be easier for you to understand and comprehend the concepts. Unless and until you interact, or you are just sitting and watching the video, it is not going to help. You have to supposed to be interactive. You are supposed to engage yourself. So constantly write down your answers in the comment section. That chat box, you can use it freely. You can write it again and again and again, so that you will be in contact. You won't get bored. Like, so please give me the answer. What is the direct variation and which is indirect variation in this case? A very simple question is being asked. You just have to be engaging. You constantly write down. You constantly write down in the chat box. Only then you will be feeling interactive. You will feel connected. Okay. So what is the indirect one? Okay. So indirect variation is case 1. Everybody agrees. Case 1 is indirect. So this is case 1. And direct variation is case 2. Right? That is correct. Now let me revise the concepts of direct and indirect variation, and then we can start. Now in direct variation, it is written something like this: x is directly proportional to y. The meaning is something like this: if y increases, x will also increase. If y increases, x will also increase. And if y decreases, x will also decrease. This is the logic of direct relation. So this is nothing but direct relationship, direct variation. Correct? Understood? This is 8th standard topic, maths. Okay, now let us move for the second point. Now if I say x is inversely proportional to y. So can I say if y increases, x will decrease. And if y decreases, x will increase. Opposite happens in terms of indirect variation, right? Indirect variation. Write it in the chat box. Have you understood this? That in indirect variation, if one value increases, other value decreases, and in direct variation, both the value will increase at the same time or decrease at the same time. Okay. Correct? Okay. PPT will be shared. Don't worry, PPT will be shared. Don't worry. Okay. Below just this particular video, the PDF will be shared. This video is being recorded, so it will be available for you. One of the reasons why I am taking it on YouTube is this video will be available to you. This will be recorded and you can view it as many times as you want for your preparation. Correct? Okay. So, okay. Now let us go with variations. X is directly proportional to y. Can I say if I put equal to sign there, I have to put a constant there? Do you remember that whenever you were solving the numericals of, suppose let's say problems of direct and indirect variation in your class 8, whenever you needed to remove that proportionality sign, you always used to put equal to sign, right? Okay, and same thing happens with indirect variation also. If you want to remove that proportionality sign, then you need to put constant value. Agreed? Constant and divided by y. So that is very much true, and you always used to put that k, right? Many students have the habit of putting k into y. But can I say I can put any value there? I can put any constant, right? So can I write down Ay also? Can I write down By also? Can I write down Cy also? Of course I can write, because constant value can be anything, correct? Okay, so I can put as if whatever I think or whatever I feel like I can put the suppose let's say value of constant. I can even put there G. I can even put there G. Even I can put it Ij there. So J by Y. Agreed? I can put any value of constant. Okay. Okay. So one thing you have understood, that to remove proportionality sign you need to put your equal to sign, right? To whenever you are removing, so you need to put a constant value. Agreed? Okay. Now let us move ahead. Let us move ahead. Now, Newton has given a very beautiful statement. Newton has given a very beautiful statement. Newton said, as he saw our definition. Suppose let us say if Newton is talking to us, and Newton, suppose let's say if this is Newton, and we are discussing, right? We are discussing our points, that is gravity is force of attraction between two particles. Gravity is force of attraction between two particles. So this is the first particle, and this is the second particle. Okay. So Newton saw this. Newton saw this, that what kind of definition we are working with. So Newton said, let me tell you in this brief. Let me give you a complete explanation. So he said, take this one particle, take this one particle, take another particle, take another particle. Now, he said these are the two particles, and according to you, they are attracting to each other, like they are attracting each other. Let us say the distance between them is d. Let us say the distance between them is d. They are separated by the distance d. And he also said, let us consider their masses also, because as you know, force of attraction also depends on the mass, like how much the bigger the body is. The bigger the body is, the bigger will be force of attraction. So he said, we will do one thing, we will give it masses also. Let us say the mass of the first body is m1 and the mass of the second body is m2. That is what he said. So he said that I am going to give you a formula for gravitational force, but you need to derive it. You need to derive it. So he said that these are the things. Two particles are there separated by a distance d, and the masses is m1 and m2. After that he said that force of gravitation is directly proportional to, force is, first point he said, directly proportional to product of masses. Okay. Now, if that is the case, and if I want to represent this, can I say force is, force I will represent with the help of F. And directly proportional. Directly proportional means what? This sign. Directly proportional. And product of masses. Now, what is the product of these masses? Product is m1 into m2, right? m2 into m2 will give me the product of masses, correct? Okay, exactly. So product of masses is equal to m1 into m2. Now we will just write down the suppose let's say formula. So that is m1 into m2. So can I say I have translated the statement into mathematics? Okay, what I have done basically is, the statement was given by Newton. And I converted that statement into mathematical expression. That is F is directly proportional to product of their masses, that is m1 and m2. Agreed? Write down in the comment section, are you agreeing that I have converted the statement given by Newton into mathematical expression? So that is the first format. Now you might think, sir, but how exactly it is directly proportional? There is no proof for it. This experiment was conducted by Newton. And it is his observation. It is his knowledge by experiments. So we do not have the proof why it is directly proportional to product of masses. This is just a result of an experiment which has been conducted by Newton. Newton has conducted this experiment and he has given the statement. So it is his conclusion of his experiment. So this experiment has already been conducted by Newton. He has given a statement, and that statement we are using. So we do not have the proof of it, like why exactly it is directly proportional. But what we have is, we have just a statement which we are writing it down in the numerical mathematical expression. So let me just write it down. So first thing, Newton said that gravitational force is directly proportional to product of their masses. But Newton didn't specify that what exactly that experiment was done by them, so by him exactly, and that was not published in our book. It is not there in our syllabus. That is of higher grade level. That is not even for 11th and 12th. That is for higher grades. That is BSc. That is for BSc. That is not even 11th and 12th. So you just have to go with the statement. So first statement is force is directly proportional to product of their masses. Okay, that is the first statement. The another statement he gave was another statement in the same way, but write it down in the comment section. Have you understood that there is no proof for this particular thing? The proof is not required because the statement was already given by Newton for an experiment which he conducted. So we don't have that in syllabus. So kindly do not ask me again and again, sir, from where it has come from. The statement has been given by Newton. We are just simply using it. We are using something which is already prepared. Are you understanding? That force is directly proportional to the product of the masses. Now I explained in detail. I have explained in detail, so I can move on. Students, they can suppose, let's say, read it again, watch this video again afterwards because it is being recorded. So you can see it later also if it is not possible for you to understand the topic in the first go. You can see it again and again. Okay. So what happened is the first statement given by Newton was force is directly proportional to product of the masses. Now Newton also gave a second definition. A second point was also given. He said force is inversely proportional to, he said force is inversely proportional to square of distance between them, Now what is he talking about? Square of distance between them. Square we can understand. What about distance? Acha, distance between the particle was given by d, right? Distance was given by d. Newton is saying that if you square it, that is inversely proportional to the force applied by that gravitational force. So force is inversely proportional to, this is inverse relation, right? Force is inversely proportional to square of distance. What is the distance between the two particles? Distance between two particles is d, right? Distance between two particles is d. Square of that distance is inversely proportional to the force. Are you understanding the second statement? Force is inversely proportional to the square of the distance between the two particles. Write it down in the comment section. Have you understood this statement? Like how we are converting to mathematical one? We are just writing down the statement and we are converting into mathematical form. F is directly proportional to d square. Okay. Write it down in the comment section. Have you understood this? Force is inversely proportional to the square of distance between them. Correct? Now, let us combine it. Now, if I want to combine, can I say if x is directly proportional to y and if x is inversely proportional to z? Can I combine it? And write it down something like this? Y by z. This is just a general format. We are talking about the rules of variation. You must have understood this in your class 8. So this is not even from class 9. I am giving you basics because some students are very much weak in mathematics. So hence I am giving you that idea, but because actually this has not to be taught. This thing is not supposed to be taught directly. The relation has to be given. But still I am giving you basics, right? So have you understood this? How to combine? So this is the combination part, wherein it is directly proportional to y, inversely proportional to z. We can combine them to create x is proportional to y by z. Right? Now, can we start? Now? Okay. So we will combine in the same way. Okay. Dhairya Pamar. Okay. Dhairya, Menti quiz is not going to be taken for this particular topic. This is being taught, so Menti quiz won't be taken right now. After the completion of the syllabus of this particular lesson, Menti quiz will be taken. Okay, so we will combine the two topics now. The first statement said force is directly proportional to the product of the masses. The first statement said force is directly proportional to the product of the masses, right? Okay, and second statement said force is inversely proportional to the square of the distance between the two, right? Force is inversely proportional to the square of the distance between the two. Now let us combine it. Let us combine both of them. If we combine it, so what we are going to get? F is directly proportional to, first we will get m1 and m2. product, right? Okay, and divided by whom? D square. Have you understood how we combined it? We have combined both the statements and we have written a combined statement that force is directly proportional to product of m1 and m2 divided by d square. Agreed? Agreed? Write it in the comment section. Have you understood this? How we have combined? Now, let us see how we can proceed in that case. So, f is indirectly proportional to m1 m2 by d square. Okay, so if I want to remove that proportionality sign, I need to keep a constant there, correct? I need to keep a constant there, only then I will be able to remove it. So let me write down constant there, constant. Okay, into m1 m2 divided by d square. Agreed? Into m1 m2 divided by d square. Now Newton has put a letter there. As you know, constant can be given any letter, but Newton decided to give the letter G there. He decided to give the letter G there, capital G. So Newton said, I will give a letter capital G there, capital G, and rest of the things will remain same. So that is m1 into m2 divided by d square. Okay, so this is the formula. This is the formula which has been given by Newton for our gravitational force. So F is equal to capital G into m1 m2 divided by d square. Now question is what is what? That G is nothing but constant value, right? So Newton said that G is constant everywhere. It is constant everywhere on every planet, every sun, every stars, everywhere. And he called that G as gravitational constant. He said G is nothing but gravitational constant. So it has a constant value, gravitational constant. There is a constant value for that, and he is using that value for calculating everything. So he said that capital G is very much same for every place in the universe. It is same everywhere, and that has been calculated experiment wise. That has been calculated by experiments. Okay, and we have been given just a value. So capital G value is 6.67 into 10 to the power minus 11. The value is capital G is equal to 6.67 into 10 to the power minus 11. But what about unit? We don't have any idea about the unit, right? So we can derive the unit of this. But before we get into that, have you understood that the formula for force is capital G into m1 m2 divided by d square, wherein F is force, this is gravitational force, this is gravitational constant. These are masses of the two bodies. And this D is nothing but the distance between the two bodies, right? Okay. Now, can we move ahead? No. We have to derive the unit of capital G. Capital D, we need the unit of that. So for deriving the unit, you can do one thing. You have to first write down the formula again. What is the formula? F is equal to capital G m1 m2 by d square. Okay, so D is the distance. Now you tell me what is the unit of force? So can I say unit of force is Newton? We have to derive the value of G, so we will keep it as it is. Okay, what about m1? M1 is the mass. How do we calculate mass? Mass is calculated in kg. So 1 kg for m1, m2 will be also kg. What about D? D is the distance. Distance is calculated in meters. Right? So I need to put meter there. But problem is that it has a square. So it will become meter square. So can I say this will convert to Newton is equals to capital G into kg square divided by meter square. Okay. Now can you transfer everything there so that we can get the unit of G? We can get the unit of G if you transfer everything to the left hand side. So capital G is equal to Newton meter square per kg square. So the unit of capital G is Newton meter square per kg square. Are you understanding this? Newton meter square per kg square. Agreed? Give me response in chat box. Have you understood this? That we are multiplying kg 2 times, so it is kg square, and meter is already square, so it is meter square. So can we write down the value now? Because Newton has already given us the value of capital G, that is 6.67 into 10 to the power minus 11. But what we have now is the unit, and the unit is Newton meter square per kg square. right? You can also write it something like this: 6.67 into 10 to the power minus 11 into this Newton meter square can also be written something like this: Newton meter square and kg raised to minus 2. You can also write it something like this, because this plus 2 will become minus 2 if it is taken to the numerator side. So even these two values are one and the same thing. So we don't have the proof of this value, that is capital G. It is a constant value and we have to remember it. Now let us discuss about this capital G. Newton has said, and this value is constant everywhere. This value is not going to change on sun. It is not going to change on moon. It is not going to change anywhere. It is going to remain same. Are you understanding this? Even if you are on Earth, even if you are on Moon, even if you are on Mars, this value is not going to change because it is universally same. Universally same. So that's why it is called as universal gravitational constant. The full name is universal gravitational constant. Are you understanding why we have given it a name like something like universal gravitational constant? Because first thing, it's constant value, it is not going to change. It is related to gravitation and it is same everywhere in the universe. So that's why it is being called as universal gravitational constant. And how do we write it? The letter denotation, we denote it by capital G. We denote this by capital G. Okay, 6.67 into 10 to the power minus 11. So agreed? Are you understanding how we have written and how we are utilizing the basic denotation like of universal gravitational constant, capital G? Now can we move ahead? Can we move ahead? Okay, so one thing is very much clear, that capital G value is not going to change on any of the planets, right? It's not going to change. Okay, so that is the formula now. So we have two formulas for force now. We have two formulas for force. First formula for force is mass into acceleration, right? So this is general formula. This is general formula. And F is also equals to capital G into m1 m2 divided by d square, which we learned right now. This is gravitational force. This is gravitational force. Special formula for gravitation. Gravitational force. Agreed? Okay, now let us see what is there in our syllabus. So that is the derivation. So that is the derivation. Universal law of gravitation is A into B, and that is suppose let's say the formula what we have seen. So we already know that the value of suppose let's say SI unit of G is Newton meter per kg square. Can you please underline this in your textbook? In your textbook, this particular paragraph is given. Can you find out the page and highlight the unit of G? Highlight the unit of G in your textbook. Do it right now, because afterwards you don't have time to read it again and suppose let's say see what is important. I will give you what is important, you just have to highlight it. Okay, and the value of G was found out. The value of G, which is 6.673 into 10 to the power minus 11. The complete value is like this, but you can just use, you can delete that letter third, you can delete that number, and you can just simply use 6.67 into 10 to the power minus 11. Now this value was calculated by somebody. This value was calculated by somebody, and the name of that person was Henry Cavendish. The name of the scientist is Henry Cavendish, and by using a sensitive balance. The device he used was sensitive balance. Now we don't have any suppose let us say information or extra syllabus over what is sensitive balance and all, but you can just say he used a device called as sensitive balance, and through that he calculated. Now his experiment is not there. His experiment is anyway too much complicated, and that experiment is not there in your syllabus. What you have right now is just a value. Anyway, that is a very old experiment, which is suppose let's say even if I explain it, it doesn't have any value, because this you can see to which year he belonged. He used to belong before 1810, so that is very old. That is very old. Even if we understand his method, there is no point in understanding, because his methods were too much old. That is one of the reasons that why the statements or the proofs are not given. You might think that why CBSE has not included the experiments of Henry Cavendish, which he used to find out the value of G. The reason is those experiments are very old. There is no point in adding them, because that information is very much ancient. We don't need it. Modern methods have changed. We have various machines to calculate. We don't need these experiments to understand. Are you understanding why these things are not given in our textbook? It is very old. So you just have to remember that this value was given by Henry Cavendish, underline it, and he used a device called a sensitive balance for finding that value. That is the only thing you need to remember. Nothing else is important. Okay, so everything has been told. Now Let us go with the next point. Let us go with the next point, and that is importance of the gravitational law, universal law of gravitation. So why to even study? The main question is why to even study. So in your textbook, on the second or third page, I think third page. Can you please come to this point, 10.1.2? Can you please come to this point? Can you please underline it, because this is very important. Just give a star mark there. Just give a star mark there, because the uses of gravitational force, this law is given there, and these uses can be asked in the exam. They can ask you in the exam what are the uses of universal law of gravitation, which we have just seen. The first thing is that we will be able to understand the force that binds us to the earth. The first thing we are going to understand is that how we are connected to earth, how we are staying on earth, and how we are not flying, or so let's say why we are not floating, why we are on planet earth. So there is force of attraction, right? That force we can study with the help of this law. This law will help us to understand what kind of force is existing between earth and humans, right? That is the first point. Second point we are going to understand is motion between moon and earth. Why moon is traveling around the earth, that is also we are going to understand, correct? Okay. We are also going to understand why planets move around the sun. That we are also going to understand in our solar system. And another thing we are going to understand is why tides are created due to the moon and sun. Tides, you must be seeing those large waves of water, those tides. So those are quite fascinating. You must have even seen in movies. There is surfing also on that water, right? Write in the comment section, have you seen in the movies? People generally ride these tides. Whenever they come, they wait for the tides in the water, and whenever those tides come, they ride on it. That is called as surfing. That is called as sea surfing. Okay, are you understanding this? So all these examples we can understand with the help of universal law of gravitation. First is about how, so let's say we are connected to earth. Second thing, we can understand how moon is moving around the earth. We can also understand how planets are moving around the sun. And the last point we can understand is how tides are created, how those big tides are created. So those are the things which we can understand with the help of universal law of gravitation. So kindly give a star point, because this can be asked in your exam as well. Okay, now for the next point we will see in the next session. Today I think it is more than enough. Let me just revise it what we have studied today, and then we will close our session. So this is just a recapitulation. This is just a, so let's say, revision of what we have studied today. So the first point we have studied today is what is exactly gravitation. So we already know gravitation is the force of attraction between any two particles. Force of attraction between any two particles. We are going to use a very simple definition. We are not going to complicate it by using fancy words. We are going to keep it very straight, very simple. Force of attraction between two particles is nothing but gravitational force between two particles. Another thing we understood that there are two formulas for force. First is F is equal to mass into acceleration, and we derived second formula with the help of universal law of gravitation, right? And that universal law of gravitation was given by Newton. So the next thing we understood was there is something called as Newton's second law of gravitation. Newton's universal law of gravitation. Universal law of gravitation, in which he said that force is directly proportional to product of the masses. Let us derive that. He said force is directly proportional to m1 and m2, and force is inversely proportional to the distance of the square between them. तो बस square the distance between the two objects, just combine them, so it is force is m1 m2 divided by d square. So you remove that proportionality sign and you can put there g and m1 and m2 divided by d square. So you got a new formula, and that is F is equal to capital G m1 m2 divided by d square. And you also understood there are certain uses of this formula also, right? So you got a second formula for force, but this is not normal force. This is what kind of force? This is gravitational force. Gravitational force. This is something very new, very brand. Gravitational force. Okay. And is there something else? Yes, there is something else as well. And that something else is what? That something else is, we also know the value of G. The value of G is 6.67 into 10 to the power minus 11, and we know the unit also. And how we have derived the unit? Let us revise it. Force is equal to capital G m1 m2 divided by d square. So you put the units of F is nothing but Newton, capital G. M1 unit is kg into kg and divided by meter square. So you just shift everything to the other side. So G unit would be Newton meter square per kg square. So you write it down. So unit of G is Newton meter square per kg square, which can also be written as Newton meter square kg raised to minus 2, because in this case it is plus 2. So you can take it to the numerator side, make it minus. And this is same everywhere. This value is same in universe. It is same in all universe, same in all places in the universe, same in all places in universe. And we also saw some uses, right? We also saw some uses. So that is what we have learned today. Now one thing which we are going to have, we are going to change, students. We are going to introduce something called as Menti quiz. Okay, we are going to introduce something called as Menti quiz for you guys. Because last time what happened was I was very much busy with my timetable, and because of which I was not able to pay attention too much regarding, suppose let's say, your whole preparation of science. Now one or two parents, suppose let us say, they personally called me from our, suppose let's say, the students who are learning in our school. The parents called me and they said that, sir, if it is possible, if you have some extra time, so kindly allot it for the, suppose let's say, practice and preparation of the students in terms of science and mathematics. That is what the parents requested, and so that request has been accepted. I was not able to do that before because I was very much busy with my current timetable with class 10th syllabus, because I teach them all the 3 subjects, that is science, maths and SST, because of which I was not able to allot too much of time. Because if I am teaching, those are not simple subjects you are trying to teach. In class 10, suppose let's see, if I am talking about science, I have to teach physics, chemistry, bio, and also for maths also, and also I am there for their SST preparation, that is history, geography, polity and economy. Now you can see, as the 3 subjects are there, so I have to take many periods on class 10th. Because of that, I was not able to pay much attention to your batch. I was only able to help you out with physics and according to the school level. But you know well and above that whatever the syllabus is there, I already have completed for, suppose let's say, the 2 lessons of physics. But some more preparation is also required. You must be coming to understand now that physics is not a subject which can be, suppose let's say, understood in a simple term, right? And that is also true for chemistry and bio. That is also true for chemistry and bio. So what we will do now is, we will engage our periods in such a way that it will help you in your preparation also. Whatever has been taught to you, that is fine. I was not able to give time. Even I had decided to give you time for your preparation of the exams, that is revision. But even that time I was not able to give. But as the request has come, so let us see, and I will change the timetable what we have. Whatever the timetable what we have, we are going to rechange it. But one thing is required is your support, because one thing, if I want to, let's say, ask you to come for a particular period, then you have to come at that particular time. I cannot always, suppose let us say, be in contact, and then suppose let's say on regular days I can take it. I have to take it according to my timetable, because my timetable is already very much filled. I have to take it according to my schedule which is available. So whatever has happened till now, but we will have a fresh revision part and all those studies in the upcoming days, right? So Menti quiz will be introduced for you. That will change your scenario in which you are studying, and then you are attending those quizzes. It will help you in your practice. And another thing is that constant requirement is there for science syllabus. Too much of revision is required. If you go with the experiments and all, we will take some kinds of experiments. I will show you what kind of things are there, and according to that we will complete. So whatever the thing has happened till now, let it be. But from now we will be changing the timetable what we have, right? So there will be some extra periods and all. I will give you the timetable. According to that, you just have to attend. Fine? Sure. So we will be, I will be dropping the message on our group. I will be dropping the message on our group. It is already there, right? Class 9th group. So just according to the requirement, you have to come. Whenever I will say that this is the time you have to come, so you just have to attend according to that time. That's it. Everything else will be taken care of. Fine? So thank you so much for today, and you can expect lots of experiments and everything else in the upcoming days. Let us see what changes can be done, because now I have got some free time now, so we can plan it. Till this moment, I was very much busy with the timetable of 10th, but now I am somewhat free. So now we can, suppose let's say, start with the preparation. So I might not have been able to help you in your previous, suppose let's say, half 9th, but this upcoming half 9th I will be definitely able to help you. ठीक है, चलो then. thank you so much for today, and we'll be meeting in the next session. Whenever it will happen, we'll meet at that time. So thank you, bye bye, and be in touch with the group. Be in touch with the group. So if there are some extra periods, if I want to take, I will just post it. You just have to attend it, and I will tell you that about Menti quiz. I will suppose, let's say, tell you how to attend it, and then you can start attending it, right? I have to give you training also how to attend Menti quizzes and how to use it. We will have that as a practice session. Okay then. So I will suppose, let's say, post those things in the upcoming time. Okay. Urjit, what you are saying, sir? If possible, please cover the deleted syllabus. Okay. Urjit will see. Urjit will see. First, I have to give priority for the syllabus which is there in our class 9, and after that, the time comes for the deleted syllabus. Fine. So you just be connected with the group. I will post everything there. According to that, you can attend. So thank you so much for today. We'll be meeting in the next session, that is in the upcoming week. Thank you. Bye bye.